A speedboat is traveling along a river. When it's going downstream, it can travel 120 miles in 4 hours. When it's going upstream, it takes 5 hours to complete the return journey. Find the speedboat's speed in still water and the speed of the current. This is very similar to the last problem, except instead of being an airplane going with and against the wind, now we're looking at a speedboat that's going with and against the current. Let's write our let statements, make our table, and jump into it. They ask us to find the speedboat's speed in still water and the speed of the current. So those are going to be our let statements. Let the boat's speed in still water be x, and let the current's speed be y. Again, we're going to organize our information into a table, and we're going to label the table just like we did in the last one. Speed, or rate, either one really, times time equals distance. Now, we need to label the two rows. And if you'll notice, the information we're given are the times, 4 hours and 5 hours. And those times correspond to when the speedboat's going downstream and when it's going upstream. So that's how we'll label the two rows. Downstream and upstream. All right, so we said that downstream the time was 4 hours and upstream it was 5 hours. Now we need to figure out the speed of the boat in each of those situations. When it's going downstream, that means it's going with the current because currents run downstream. So it's not just going to be going at a speed of x, but that current is going to push it faster by y. And then when it's going upstream, the current's going to slow it down by y. So the speeds are going to be x plus y and x minus y. Now that we have those in, we can multiply across to fill in the distance. X plus y times 4 gives us 4x plus 4y. X minus y times 5 gives us 5x minus 5y. And just like the last problem, the distance that we're given, in this case 120 miles, represents both of the distances in the problem, both downstream and upstream. So that gives us our system of equations. We're going to have 4x plus 4y equals 120, and 5x minus 5y also equals 120. We're going to do the same trick that we did in the last problem. We're going to divide each of these equations by a number to get smaller coefficients and simpler equations to work with. In the first equation, each term is divisible by 4. So dividing by 4 gives us x plus y equals 30. And in the second equation, each term is divisible by 5. So when we divide by 5, we get x minus y equals 24. And again, we're in an easy position to use elimination. If we add these two equations together, we end up with 2x on the left-hand side because the y's cancel. And then on the right-hand side, we end up with 54. And when we divide both sides by 2, this gives us x equals 27. Now to figure out y, we can substitute this into any of the equations we have already. I'm going to substitute it into x plus y equals 30. That gives us 27 plus y equals 30. And when we subtract 27 from both sides, we get y equals 3. So we go back to our let statements now. The boat speed in still water was x, which we can see is 27 miles per hour. The current speed was y, which was 3 miles per hour. And so we end with our conclusion. The speedboat's speed in still water is 27 miles per hour, and the current's speed is 3 miles per hour. And that is our final answer.